Alright, today we're going to be talking about 13.8, which is nonlinear functions. So we know a linear function is a non-vertical line that we can create from points on a graph. A nonlinear function is a function that does not have a constant rate of change. So my slope is not going to be constant, which means it is not a straight line. So that is a nonlinear function. And then a blank function, it takes the form of a parabola, and a parabola is a U-shaped curve that can go up or down. So that means it can look like this, or it can look like this. And that is called a quadratic function. And it's y equals x squared. So anytime the x is being squared, that is always going to be a quadratic function. And then a function that takes a V-shaped form, you should be able to figure this out because we should know what these two little lines around our x means. So go ahead and pause this and see if you can figure out what that means. So you should be able to figure out that is an absolute value function because this is the absolute value of x. So anytime we have an x squared and it's a quadratic function, we're going to have a u on our graph. Whenever it's an absolute value, we're going to have a v. So there are two ways to determine whether or not a line, to determine whether it's linear or nonlinear. One, you can find the slope. All points have to have the same slope, so if they do not, it is nonlinear. The second is to examine the graph. So if it's not a straight line, it is not linear, and if the rate of change is not constant, it's not linear. So we are going to apply this on the back, so go ahead and flip over your paper. So we are going to be using function tables and also random points to be able to figure out whether it's a linear or nonlinear graph. So like I said on the other side, there's two ways. You can find the slope and compare the slope. If they are not all the same, then it is non-linear. If they are all the same, it is linear. Or you can look at a graph and tell from there. When we're not given a graph, you can graph it and look from there, but you don't have to if you don't want to. I'm going to draw a couple graphs down here as well to help us see what we're looking for when we are just given a graph. So in case you forgot, to find slope, slope is always the change in y over the change in x, so it's always y2 minus y1 over x2 minus x1. So what I'm going to do is I'm going to pick some points from A, and I'm going to check to see whether or not it is whether it's linear or a nonlinear function. So to be able to tell what x and y go together, it's the ones that are in the same row or the same column, depending on where your x's are. If these would have been this way, where x is here, y is here, then it would go this way, but since they're listed this way, this is how we're going to do it. So these all go together. And then we're going to find the slope of 2 points. So I'm going to pick these two right here. I have -1, -8, and -2, -11. So I'm going to check to see what the slope of those 2 points are. Remember, it's y2 minus y1 over x2 minus x1. So I'm going to take my second y minus my first y over my second y minus my first, over my second x minus my first y. So I have -8 minus -11. I would use KCC, keep the first, change the add, change the sign of second number. Now I have -8 plus 11, different sign, so we'd subtract. 11 minus 8 is 3. 11 is the bigger number, so it stays positive. We would do the same thing down here, different signs, so we're going to subtract. 2 minus 1 is 1. 2 is bigger, so our it would be positive. Sorry, lost my train of thought. And then you can find pick any other 2 points you would like. I'm going to pick the 2 kind of right next to it. So I have 0, comma, -7, and 1, comma, -8. I'm going to check those and see what that slope is. So I have -8 minus -7 over 1 minus 0. Okay, so you see -8 plus 7 is -1. 1 minus 0 is 1. So that means this slope is -1. This slope was 3. So since my slopes are not the same, this is going to be a non-linear function because they are not the same. So you should be able to pick any 2 points you want from that graph to figure out whether or not it is linear or non-linear. So on B, I want you to do the same thing. I want you to pick 2 points, and I want you to find out if this if this table would create a linear or a non-linear function. So go ahead and pause this and do that now. Alright, so I picked 3, did one here, here, and here. And each time I did it, so the first 2 times I did it, I got -3 both times. But I just wanted to make sure that it wasn't just these 2, so I picked another 2 points. So I also did these last 2. And I still got my slope to be -3. So I checked 3 different points, and they are all the same, so that means it is a linear function. Alright, on C and D, now you're just given the ordered pairs. And I have a little note here, find slope for all 3 points, because these 2 slopes may be the same and these 2 slopes may be the same, but these 2 may be different. All 3 of them have to be the same for it to work. So I'm going to do this one first. So I have 2, 2, and 4, 3. So there's my first x, first y, second x, second y. So I have 3 minus 2 over 4 minus 2. 3 minus 2 is 1. 4 minus 2 is 2. So then I can do these 2. I'm going to do 4, 3 and 6, 4. Same thing, second y minus the first y. 4 minus 3 over second x minus the first x. 6 minus 4, 4 minus 3 is 1, 6 minus 4 is 2. So far my slopes are the same, but I still want to check the first one and the last one. They all need to be the same. So I have 2, 2 and 6, 4. So I would have 4 minus 2 on top, 6 minus 2 on bottom. 4 minus 2 is 2, 6 minus 2 is 4. I'm sorry, I did not realize you could not see that. And I get 2 4s. Now some of you say, well, that's not the same numbers, but can we reduce this? We can. Both of these can be divided by 2. So that means my slope is 1/4. So this one is a linear function. So you want to do the same thing with 3 points. You want to compare -3, 3, the slope of -3, 3 and -2, 2 with the slope of -2, 2 and -1, 1, and also of -3, 3 and -1, 1. So I want to compare these 2 points, the slope of these 2 points, the slope of these 2 points, and the slope of these 2 points. So go ahead and pause this and find all these slopes and find out, is it linear or is it nonlinear? Alright, so you should have got that all of your slopes are -1, so this is also a linear function. If these two would have been -1 and this one would have been +1, it would be nonlinear. So all three have to be the exact same. Alright, I said I was going to draw a couple graphs. If you have room, you can do this. You don't have to. Let's make it 3. So based on looking at these graphs, we want to figure out if it's a linear or nonlinear function. So remember, a linear function is just a non-vertical line, whereas a nonlinear function is it's not a straight line. It can be curved. It doesn't have a constant rate of change. So if I look at this one, it's not vertical. It is a straight line. So this one would be considered linear. This one, it is not a straight line because I go down. If it was a straight line, I would keep going down here. But instead I come back up. It's a V. So this one would be nonlinear. And this one, it's not a straight line. Remember, this is what we call parabola. So it would be nonlinear. This would be considered a quadratic function. And this one would be our absolute value function. I just want to make sure we saw those as actual graphs because you will have that on your homework tonight as well. It'll ask if it's linear or nonlinear, and then it'll ask if it's a quadratic. So remember, a quadratic is only if it makes an upside down U or a right side up U. All right, this is the end of 13.8 nonlinear functions.